This is Algebra 2 lesson 3-3, solving systems of inequalities. You can solve a system of inequalities in more than one way. Graphing the solution is usually the most appropriate method, and probably up until now is probably the only method you've ever used. The solution is the set of all points that are solutions to each inequality in the system. Other than graphing, you can also solve a system of inequalities using a table. Let's assume that x and y are whole numbers. Using a table really only works when you assume this, that your answers are whole numbers. What is the solution of the following system? Y plus x is less than or equal to 8, and y minus 1 is greater than 2x. Now, what we're going to do, since whole numbers means 0, 1, 2, 3, 4, 5, it doesn't include any negative numbers, that would be integers. Since we're talking only about whole numbers, that limits the types of numbers that we will be working with, which means it determines which inequality we'll work with first. If we look at our two inequalities, the first one where it says y plus x is less than or equal to 8 has a finite number of solutions, which means really the only solutions it can have is 8, 7, 6, 5, 4, 3, 2, 1, and 0. It has 9 possible solutions. Since the other inequality, y minus 1 is greater than 2x, if it's greater than, that means it's had an infinite number of solutions. It's 0 to infinity. I want to work with something that I don't have to list all the possible solutions all the way to infinity, so I'm going to work with the first inequality. So we're going to make a table of values for x and y that satisfy the first inequality. Okay, so the first thing I'm going to do is I'm going to make a table of values. I have an x, and I have a y, and I'm probably going to have more than one possible y. So the first thing you're going to do is what happens, and like I said, I can go all the way to x equaling 8. I won't need to go that far, but let's start with 0. Okay? If x equals 0, we're going to work with the first inequality. The first inequality, if you remember, I said we're going to work with the first inequality because there's a finite number of solutions. So if x equals 0, then y could if x equals 0, then y plus 0 is less than or equal to 8. In other words, y is less than or equal to 8. So all my solutions for y are 8, 7, 6, 5, 4, 3, 2, 1, and 0. Those are all my possible solutions. If I let x equal 1, I'm going to do the same thing. If x equals 1, I'm going to have y plus 1 is less than or equal to 8. So basically, y is less than or equal to 7. Okay, so I'm going to have 7, 6, 5, 4, 3, 2, 1, 0. And so on and so forth. If x equals 2, it's going to be 6, 5, 4, 3, 2, 1, 0. If x equals 3, it's going to be 5, 4, 3, 2, 1, 0. If x equals 4, 8 minus 4 is 4, so it'll be 4, 3, 2, 1, 0. I'm going to stop at that point right now because I'm now going to start looking at the second inequality. Now I'm going to check each pair of values to see which satisfy the other inequality. In other words, there are solutions to the second inequality. So let's take a look at the second inequality. I'm going to erase this for a moment because I need space on the table so you can see it. Let's look at the second inequality. Y minus 1 is greater than 2x. Okay. I prefer to put it in y form, so I'm going to add 1 to both sides. So y is greater than 2x plus 1. So let's figure this out. If I was to plug in 8, if I was to plug in 0 and 8, okay, because we're looking at all the solutions. If x equals 0, these are all the possible solutions for y. 8, 7, 6, 5, 4, 3, 2, 1, 0. So if x equals 0 and y equals, okay, so if x equals 0 and y equals 8, right, 8 is greater than 0 plus 1. That's true, so that one works. Okay, let's look at if it's 7, I would have 7 is greater than 1. That's true. Because basically it's saying 8 is greater than 1. Okay, which means any number greater than 1. So any number greater than 1 would be 8, and 7, and 6, and 5, and 4, and 3, and 2. Greater than 1 does not include 1. So that's all the possible solutions if I use 0. Of course, obviously 0. If I use x equaling 1, I'm going to have, okay, y is greater than 2 times 1, which is 2 plus 1, so y is greater than 3. So all the numbers that are greater than 3, which in this case would be 4, 5, 6, and 7. Okay. So x equals 0, you get 2, 3, 4, 5, 6, 7, 8. If x equals 1, you get 4, 5, 6, 7. If x equals 2, I'm going to have y equals 4 plus 1, excuse me, greater than 4 plus 1. So y is greater than 5. So that would be 6. Okay. If x equals 3, 3 times 2 is 6 plus 1 is 7. That's not on there. I am now done at this point in time. So these are the solutions. All the things that I've boxed in blue are my solutions to the system, and I would write them as coordinate pairs. So my possible solutions are 0, 8, 0, 7, 0, 6, 0, 5, 0, 4, 0, 3, 0, 2, 1, 7, 1, 6, 1, 5, 1, 4, and 2, 6. Now nobody wants to do all of these blessed ordered pairs all of the time, which is why we don't often use a table. But it is important to understand how a table would work to be able to solve this system of inequalities. The most common thing we do when we solve a system of inequalities is to graph it. When the variables of a linear inequality represent real numbers, a graphed solution consists of a half plane and possibly the boundary line. For two inequalities, the solutions of the overlap of the half planes is your solution. In other words, when you shade it where the two shadings overlap, that's the system, that's the solution to the system of inequalities. Remember, with your boundary lines, if it's a dashed line, if it's a greater than or less than, it's a dashed line. If it's greater than or equal to or less than or equal to, it's a solid line. If it includes the value, then the boundary line is a solid line. If it doesn't include the value, then the boundary line is a dashed line. So let's take a look at this first problem here. Solving a system by graphing. Okay, x minus 2y is less than 6, and y is less than or equal to negative 3 as x plus 5. Okay, so remember what I said earlier. If it's written in y equals form, you can look at the inequality and determine whether you're shading without having to use a test point. If it's not written in slope-intercept form or y equals form, you have to use a test point. And sometimes it's a good idea to use a test point just to try to trigger your brain and to make sure you're doing it right. If I look at this first inequality here, it's not written in y equals form, so I'm going to put it in y equals form. Negative 2y is less than negative 8 plus 6. If I divide by negative 2, I get y. Reverse my inequality since I divided is greater than 1/2 x minus 3. Okay, so that is my inequality for this. Y is greater than 1/2 x minus 3. So graph negative 3. So I'm going to go down here to my graph paper here. 1, 2 down to negative 3, and then I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. It's greater than, so it should be a dashed line. So now I need to have my line be dashed. So I'm going to put it as a dashed line. And use a straight edge to make it accurate. And then have where it needs to be. See how it goes next to move. There we go. It's not right. Place it as well. All right. So now that we have this dash line, this is equation number 1. I'm going to label this equation number 1. It is greater than, so I should be shading above it. So I'm just going to draw. I could shade it. Here, let's do. Hey, I'm going to actually shade it. I'm going to shade above it. Okay, so I'm going to take yellow and I'm going to shade above this. Okay, so that's the solution to this particular inequality right here. Now I have to graph the second inequality. Let's take our second inequality, which is already written in slope-intercept form. Isn't that nice? So I go up 5, 1, 2, 3, 4, 5. My slope is down 3, right 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. And I can graph this line as well. So we'll go there. It is a solid line this time and not a dashed line. So I will pull this. So then we have this line right here, which is a solid line. That's so much for my line. I wanting a line. Solid line. Let's see if we'll actually draw this one. There we go. Much straighter if I don't draw it myself. Alright, so let's move this to where it belongs. And then that would be equation number 2. It was less than or equal to, so we would shade below it, the left side of it. Alright, so that would be shaded. Okay, so that would be this way. Which means the solution is where the two things overlap. Which means I'm just going to erase where they don't overlap. So which means that's the solution to this inequality. Which a lot of times I do by drawing little arrows so that I only have to shade once versus shading twice, because shading twice gets messy, and sometimes it's really, really hard to read. I would highly suggest you don't shade with ink in case you make a mistake, because it's really hard to erase ink. Or a pencil is fine when you don't do it. You draw it. All right, let's take a look at the second one. Right, if I take a look at my second inequality here, I'm going to have to solve this first one for y. So y is greater than negative x plus 3. And the second one is already in y equals 1. So my first inequality here, my first inequality y is greater than negative x plus 3. So go up 3, 1 is 3. Slope is down another 1, down another 1, down another 1. And I graph this with a dashed line. Somewhat of a purple color. And I didn't pull my line again. I don't know why it's not pulling my line. Going for it. What can you do is remove this? Oh, now then dash it. I'm just having a whole lot of trouble with this, aren't I? Hey, here we go. 15th time in the charm. Hey, I actually made it through the points pretty well. So this is equation number 1. Equation number 2, y is greater. Oh, wait. First of all, this is a greater than, so we would shade above it. So I'm going to just tell you I would shade this way. I like little arrows because it's easier. Second equation, inequality, y is greater than x minus 1, so go down 1. It's up 1 over 1, up 1 over 1. Again, I need to get line the way I need it. And then it would be like so. Almost a nice spot, not quite. There we go. And I'm going to shade that one as well. This one is greater than, so it would be going this way. So where do they overlap? They overlap here in the middle. So I'm going to shade right here where they overlap. Again, make sure you don't shade so close to your dash lines that we can't tell if they're dashed or solid. Right? So we have labeled both equations. By x and y axis. I think I keep forgetting to do that. Yes, I do. Make sure you always make sure you label your axes. And there's the solution to that inequality. System of inequalities. Let's take a look at some word problems. Okay. An example. An exam has two sections, a multiple choice section and an essay section. You can score a maximum of 100 points. To pass the test, you must get at least 65 points on the essay. Find a system of inequalities to model passing scores and go off the system. Okay, so we have two types of questions. We have multiple choice questions and essay questions. So I'm just going to let one variable be multiple choice and one variable be essays. I'm going to let x equal multiple choice. And I'm going to let y equal essay. Okay, and it says we can score a maximum of 100 points. So it doesn't matter how many points we get in multiple choice and how many points we get in essays. We have to only score a maximum of 100 points. So my first inequality is going to be x plus y is less than or equal to 100. The points I score off my multiple choice plus the points I score off my essay have got to be less than or equal to 100. Because there's no extra credit. The second thing says, to pass the test, you must get at least 65 points on the essay. So you have to get at least 65 points on the essay. So that's the second inequality that we're going to write. So my essay has got to be greater than or equal to 65 points because that's what it said. Okay. So I'm now going to graph these two inequalities. And my next piece of graph paper here. So since we know that we can't score a negative number of points on this test, you do not need all four quadrants. You're not going to use all four quadrants. I'm just going to use quadrant 1. Since I can do that, I'm just going to simply label what I'm going to do. Okay? So down here, let's say this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 30, 140, 150, 160. Grabbing like 10 is going to be labeling every few of them. Okay. And 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 30, 120, 160. There we go. So this would be essays. Essay points. And down here we're going to multiple choice. Okay, now I have two inequalities I need to graph. The first one would be easier to graph by using intercepts. Because I look at the first inequality, x plus y is less than or equal to 100. If I use intercepts, oops, if x is 0, y is 100, if y is 0, x is 100. So it's going to be at 100 and 100. So 80, 90, 100 is there. 80, 90, 100 is there. And since it's a less than or equal to, my line would be solid. So let's graph that line. So there's a graph of that particular line. And since it's less than or equal to, we know we would shade below that. So is that the way? The second inequality is y is greater than 65, greater than or equal to 65. A y is greater than or equal to 65 is a horizontal line. That's 65. So 40, 50, 60, 65 would be about there. So now I need another solid line. At 65. There. And that's my second inequality. And it would be greater than or equal to 65, which means it has to go up this way. So the only points which are in that little section are right here. Okay, so essentially I'm fairly limited because I can't get 10.5 questions. I can't get 4.5 multiple choice questions correct. Okay? But I can get, this tells me it's the point values for each. So I need to get, so if I chose a point within this red section, I could choose like this point right here. So if I chose this point right there, I would need to get 10 points on multiple choice questions and 70 points out of the essay, and that would give me 80 points which means I would pass the exam. Any points values in here, and I would pass my exam. All right, the last thing we're going to look at is a system of inequalities that can include non-linear inequalities. Right? Can also be solved graphically. Let's take a look at this. We have y is greater than or equal to 3, and y is greater than the negative absolute value of x plus 2 plus 5. Okay, so in other words, we have an absolute value graph and a linear graph. A linear graph is pretty easy. Y is greater than or equal to 3. And if I was to graph my inequality as y is greater than or equal to 3, let's do this first. One line style. I need a solid line. It's good. I'm going to put it in green. So it's going right there. And 1, 2, 3. Y is greater than 3. Right there. And line y is greater than 3. First inequality, and that would be shading above it. The second one now is an absolute value graph. We know because of this negative that's outside the absolute value, it's reflected across the x-axis, so it's pointing downwards. So I know my vertex is a maximum point. And my vertex, if you remember h and k, the vertex is a negative 2, 5. There's my vertex. So I'll plot the point negative 2, 5, negative 2, 1, 2, 3, 4, 5. My slope is negative, so it's going to be pointing downwards. So it's going to look something like this. And it's greater than, so it's dashed line. So I'll take care of that. So I will have here, here, and there's my graph that way. And the 2. Now, here I actually have to think about it. It's greater than, since it's in y equals form, greater than would be outside of it, not inside of it. So I would be shading this way. So the solution for this system of inequalities would be all of this part shaded right here. That's the solution to one linear and one nonlinear system. Let's take a look at letter B here. Y is greater than or equal to negative 2x plus 4, and y is less than the absolute value of x minus 4. So let's take the first one, which is a line. So we're going to go up 4. 1, 2, 3, 4. Slope is negative 2, so down 2, right 1, down 2, right 1. It's a line. Okay, so I'm just going to make sure I have my line. Since it is greater than, we would be graphing this, shading this out of it. The second one, in it again, is an absolute value inequality, which the vertex is at 4, 0. So I'm going to get to 4, 0. 1, 2, 3, 4, 0. And the slope doesn't have a negative, doesn't have a number in front of the absolute value, so my slope is up 1 over 1, up 1 over 1. Okay, again, it's a solid line. There we go. Lock that in place. Lock this in place. Okay, and this would be shaded less than, means not inside, but outside of it. And if you don't believe me, you can put a test point, 0, 0, since it's not on 0, 0. 0 would be less than the absolute value of negative 4. Okay. Actually, I can't use 0, 0. I could use 1, 0. If I wanted to test this, I could use a point 1, 0 if I wanted to. So I tested it, 0 would be less than or equal to the absolute value of 4. 0 is less than or equal to the absolute value of -3. The absolute value of -3 is 3. 0 is not less. 0 is less than or equal to the absolute value of 3. So we would shade where 0 is. So we would shade on the outside of this. Okay, so where do these things overlap? We happen to overlap right here. So that would be the solution of this particular inequality. And again, make sure that you have labeled both your inequalities and your x and y axis. And that's the solution of inequalities.